This specialized 3D printer just received a record-breaking throughput for modern 3D printing. It can create structures the size of a human adult in just a few hours. That's printing about 7 millimeters per minute. With this device, the team may have just cracked the code on how to utilize the technology as an efficient manufacturing tool. This means we will finally have the fast, precise, and versatile 3D printing device we have all been waiting for. It just took a little bit of thermostatic control to get there. Let's rewind a bit. Firstly, this particular 3D printing process is called stereolithography, or SLA. SLA printing is considered one of the higher-end 3D printing technologies because the objects can have smooth, detailed features with obvious precision and can be made with a variety of materials. They work by using a light-reactive thermoset resin, which, when exposed to certain wavelengths of ultraviolet light, polymerizes. So layer by layer, the object is solidified while pulled out vertically from a vat of resin. And as awesome as these printers are, researchers have had trouble making the machines larger and faster.
So here's the interesting thing. When you go fast and you go large, you can really change the way we think about manufacturing. If you really want to be able to make inroads, you want to be able to make large batches and large parts in addition to small parts. That's what this printer allows you to do.
Their machine is known as HARP, short for High Area Rapid Printing. Its success hinges on its innovative design, one that's capable of thermostatic control of the giant vat of liquid.
We have a liquid, think of it as liquid Teflon, that basically flows over the glass window that the light is shining through to generate the part. That non-stick liquid is keeping the part from adhering to the window, allowing you to continuously print, which gives you speed, and it is removing the heat as it's generated. So we're almost unlimited in terms of size in principle.
With HARP's fluorinated oil, it can do it with at least 3 different kinds: hard plastic, elastic rubber, or ceramic.
We can make all sorts of materials that are important in the medical industry. We're talking about dental industry, to tennis shoe soles, to car parts, to airplane parts. We can make construction parts. Really almost anything that you can imagine and make out of polymer precursors, and that's a lot of materials.
And its special features don't stop there. HARP is also able to print both large and small items, which is unprecedented in the 3D printing world. Usually the size of the printer determines the tasks that it can handle, and it varies from waiting for hours to days for a final product. Altogether, HARP is reportedly said to be the largest and highest throughput printer in its class. So where do we go from here?
The amazing thing about this technology is the pace at which it's being developed. We're going to have commercial printers within 18 months. We are now on a Gen 3 printer that actually prints even higher quality structures than what we have in the science paper. Pretty exciting and really rapid development.
Up until this point, 3D printing has been restricted practically while remaining powerful in its conception. With a printer like this, the team could be spearheading a future without limitations. If you like this episode, let us know over on Twitter and Instagram. We're @Seeker. Thanks so much for watching, and I'll see you next time.